start this. Here we go. We're going to do slope. That's going to be rise. Oops, over run. So we rise on the y-axis, y minus y over x minus x. And if I have x and y and x and y, I need to do the y's first. 7 minus 3, 7 minus 3 divided by 5 minus negative 3. 5 minus negative 3. 7 minus 3 is going to be 4, and 5 minus negative 3 is going to be 8, and we always want to reduce our slopes, so the slope is 1/2. I think everybody who did that got it perfectly correct. So what is the length? Length is another word for distance. So distance, we're going to do that face, x minus x squared plus y minus y squared. Here the x's have to go first. So we're going to do 5 minus negative 3 squared plus 7 minus 3 squared. Notice that I get these same numbers, just in a different order. So the square root of 8 squared plus 4 squared is going to give me the square root of 64 plus 16, or the square root of 80. And then a lot of people figured out what that was as a decimal, and it's 8.9, if I'm not mistaken. Is that correct? Sweet. Midpoint, we're going to find the average. You have two endpoints and you want to find the middle. You do x plus x divided by 2 and y plus y divided by 2, right? So it's the same order as up here. We're just dividing by 2 and adding. So the combinations are all different. You got to know which ones the y goes on top, which ones the x goes first, and which ones you add and which ones you subtract. It's all different combinations of stuff there. So 5 plus negative 3 divided by 2, and 7 plus 3 divided by 2. It's going to give me 5 plus negative 3 is 2, divided by 2 is 1, and 7 plus 3 is 10, divided by 2 is 5, right? The only thing we're missing here is the other end point. Other end point where you make the table, right? The end, the middle, and then the other end point. Make sure the middle goes in the middle. Questions on that? Pretty straightforward. I think everybody did really well. Let's see if I can pull up the chat. Not going to work today. All right, so with a rhombus, right? We know a rhombus is a square that's been run over by a truck. That's my weird way of remembering what rhombuses are. So the key thing here is rhombuses all have congruent sides, right? If they're congruent, then you set these guys equal to each other. 6x minus 5 equals 4x plus 13. Move the smallest x and move the number, the constant, to the other side. The x's cross out, the 5's cross out. We get 2x equals 18 and x equals 9, right? Questions on that? Rhombus's sides are equal. Rhombus's sides are equal. So I'm going to skip slide 3 because it's the same on mine and go to slide 4. What's the relationship, ladies and gentlemen, between the circle center and the equation? What's their relationship? Are they the same number? I've got a 4 for the x, and I've got 4's all in here. They are the same number. What about the sign? Is the sign the same or opposite? Opposite, absolutely. So we're going to cross off both of those minus 4's because I know I need a plus 4. If I need a plus 4, that means I need a minus 1. So I need a minus 1 or a minus 1. I've already crossed off A, already crossed off B. Now I can cross off D, and C is my answer. Guys, these are easy questions. Just remember that the center of the circle and the equation have the same number and opposite signs. If you are ever concerned, use Desmos, right? Use Desmos. Desmos is your friend. All right, question number 5. We looked at a similar one yesterday, so let's see if we remember how to do it. The ratio of the lengths of the radii, what's the power for radii? Is it a power of 1, a power of 2, or a power of 3? Radius is a length. Length is a line, so that's just going to be like meters, inches, centimeters, whatever it is a power of 1, right? What is the ratio of the volume? Volume is always cubic. Centimeters cubed, feet cubed, right? When I'm talking about volume, I want what fills it up, right? I think of little sugar cubes filling up stuff. Remember, they're cubed. So if I want to go from a radius that's a power of 1 to a volume that's a power of 3, I just take that 3 and cube it, take that 5 and cube it. So if you go into your Desmo, into your calculator, into your whatever application you use, what is 3 cubed? 3 times 3 times 3. 27, absolutely. And then same thing with 5. 5 cubed is going to be 125. Ladies and gentlemen, this question is super easy as long as you know how to translate it, right? Until you know how to translate it, it is mystifying. But if you can remember that radiuses, lengths, circumference, anything that you would measure with a line, with a ruler, has a power of 1. Anything that has a volume is a power of 3. And then anything that's a surface area is a power of 2, right? Questions on that? I know it's brand new. Normally, we would spend a handful of days on that. Question number 6 is one of those plug and chug problems, right? You just need the formula from the formula sheet. So volume of a pyramid is 1/3 the base times the height. Now the tricky part here is that's a capital B, right? So if I come back over to my, oops, that's not my picture. That's later. The volume is 1/3 the base times the height. Anytime you have a big B, that's the area of the base. Okay, so I want this whole base, not just one side of it, but the whole area inside. So big B is 12 times 9. Big B equals 12 times 9. Anybody got a calculator handier than mine? What is 12 times 9? I spilled coffee on my calculator today. It doesn't want to work. So I got 108. Anybody else confirm that? So volume of that pyramid is going to be 1/3 times 108, and then times the height. Here the height is given to us. That's very convenient because sometimes it's not. So now in your calculator, 1/3 times 108 times 8. 1/3 times 108 times 8. Which answer choice did we get? Did you get? I got C as well. Excellent. Okay. Those problems, you just have to reference the formula sheet. All right, moving along. Question number 6. A company is creating a new cylindrical container to replace its original cylindrical container. Oops. So I've got 2 cylinders. This is a lot of words for Miss Doherty, right? I really don't like to read very much, but I know I've got a new cylinder and I've got an old cylinder, right? So I'm going to start to illustrate it. The new cylinder will have 4 times the volume. So 4 times the volume of the original container. The height of the new container will remain the same as the height of the original container. So I didn't draw that very accurately, but the height and the height are equal. The length of the radius of the new container will be, 2 times the length of the original container, 4 times the length of the original container, 8 times the length of the original container, or 16 times the length of the original container. So let's start with the volume of a cylinder. So volume of a cylinder is pi r squared h, right? So V equals pi r squared h. If I know the h's are congruent, the h's are going to be the same, I can just kind of remove that from my formula. Does that make sense? So if the volume of this newest cylinder is 4V and the volume of the original is 1V, I want to know what happened to the radius. So if I do 1V equals pi r, are you guys still with me? My computer just went crazy. If you're still with me, bear with me. I lost Zoom, I think, and I'm not sure where it went. I can see the chat. Come back here. Pi r squared. It's probably the coffee that I spilled all over my computer and my calculator that's causing me issues. So if I divide all this out, 1V equals pi r squared divided by pi and divide by pi, then the radius squared equals 1 divided by 3.14 r squared equals 0.31. And then we take the square root and take the square root. Square root of 0.31 r equals 0.55, right? And then I take 4V and I set that equal to 1/2 pi squared. And I do the same thing, divide by pi and divide by pi. So now 4 divided by 3.14 is 1.27 equals r squared. I just am solving this equation, right? So then I'm going to take the square root and the square root, 1.27 square root r equals 1.12. How are these two numbers related? Is 1 2 times, 4 times, 8 times, or 16 times? When you multiply, or how many 0.5s go into 1.12? It's twice as big, right? So all I did was I set this equal to each other, used the volume formula, took out the heights because the height of both cylinders is going to be the same, and then solved for r. The small r is 1/2 and the big R is 1. So that's twice as big. Just a lot of algebra, which we really haven't had a whole ton of time to practice with. All right, tell me what you know here. Which can I mark? SOT is 68 degrees. So is that the central angle or the inscribed angle? SOT from S to O to T is the inscribed angle. So that's 68 degrees. That means this arc ST is also 68 degrees. And the inscribed angle, is that smaller or bigger? The inscribed angle is small and the arc is big. So to go from the big to the small, you've got to divide by 2, right? So this is going to be 34. Do you remember that from the circles unit? Maybe kind of, sort of. Okay, last thing, guys. Two cylinders, a sphere, and a cone are shown. Select two objects with the same volume. What I need everybody to do is choose a shape. Okay? Everybody choose a shape and find the volume of that shape. I'm going to give you 2 minutes to do that. So at 7:55, I need everybody to put some kind of volume in the chat. I'm going to stop sharing for a second while you do that so I can see if I can fix my computer. Morning, Isis. Morning, Victoria. We are working on the last question of the warm-up. So everybody's choosing one shape to find the volume of, and we are going to start talking about it right now. So you guys had great timing. All right. So if we look at this, what volumes did you get? In the chat, anybody find a volume? Cone 28. So volume of a cone is 1/3 pi r squared h. 1/3 pi r squared h. Oh, the cylinder? Say that again?
For the figure that you're on, figure C, I got 32/3 power.
16 times 2. I got 33.5 centimeters when I put this in the calculator. So then which cylinder did we get 28 on? The first one or the second one? Figure A, okay. So volume is pi r squared h. So if we come over here, pi r squared h. If the diameter is 3, then the radius is 1.5 and the height is the 4. So if I substitute there, we get pi and then 1.5 squared and 4. So 3.14 times 1.5 squared times 4. 28, absolutely. 28 centimeters, and this is volume, so it's going to be centimeters cubed. I should have put that for figure C. How about B or D? Did anybody do B or D?
Mine is different light.
That's okay. 32 over 3 pi?
Yes.
So the pi is going to be multiplied. It's not going to be in a denominator. So when you do that, it's going to be 32 over 3 times pi, I think. 32 over 3 times pi. So let's see how that works out. Volume of a sphere is 4/3 pi r cubed. 4/3 pi r cubed. So 4/3 pi r cubed. All of this is in the numerator with the 4. The 3 is the only thing being divided. So when you put that in the calculator, you're going to do 4/3 and get 1.33. And then multiply by pi. And then here, the radius is going to be 2, right? So 2 cubed. If you put all of that into the calculator, 4 divided by 3 times pi, 4 divided by 3 times pi, times 2 cubed, you should get 33.5. 33.5 centimeters cubed. So these two are going to be the same. And I think if you do 32 divided by 3 times pi, you're going to get that. 32 divided by 3 times 3.14 is 33.49. So yeah, that's perfect. And then my cylinder over here is going to have the same thing. It's going to be pi r squared for the base times the height. So pi r squared times the height. This, my friends, is the height. And then the radius is 1. So you got to make sure you find the radius. So 1 squared. And the height is horizontal here. That weirds a lot of people out. It's like the length of a pipe instead of the height of the pipe. So 3.14 times 1 squared times 6 is going to be 18.84 centimeters. And again, that's cubed. Okay. This is what I call a time-sucking problem. It's not that any of them are really that hard. It's just that in order to get the answer correct, you've got to do 4 gigantic problems, right? Reference that formula sheet, take your time, double-check your calculations twice just to make sure. And then you would answer figure B and figure C. Okay? Questions on that? Questions number 4 and 5. So questions 1, 2, and 3 look really straightforward and really good, but I did want to talk about 4 and 5. So is everybody with me? You know where we are? January 19th folder inside the cylinders. A traditional square bale of hay is actually in the shape of a rectangular prism. The dimensions are 2 by 2 by 4. So that's not pictured. I'm going to sketch it, right? So 2 by 2 by 4. How many square bales of hay contain the same amount of hay as one round bale of hay? So what they're asking me is how many rectangular prisms can I fit inside this bale of hay, right? That's what it's asking me. So first thing I need to do is find this volume. So the volume equals length times width times height. So volume equals 4 times 2 times 2. What is 4 times 2 times 2? 4 times 2 is 8, and then 8 times 2 is 16. So 16 feet cubed, right? So the volume of a square bale of hay is that 16 feet cubed. Use the picture to find the volume of the round bale of hay. So it says round, but this is really a cylinder, right? It's what we just did. So pi r squared h equals the volume. And I know that the diameter equals 4, so the radius equals 2. So pi times 2 squared, and then this is the height, even though it's laying on its side, right? So in your calculator, what is pi times 2 squared times 5? Anybody? I got 62.8. Did you get that?
Yeah.
So then how many small bales of hay fit inside the big bale? Well, to do that, we need to divide. So how many 16s are there in 62.8? So 62.8 divided by 16 equals
4.
3.925, or rounded to the nearest whole number is going to be 4. So not all your questions are going to be super straightforward like the first 3. In fact, most of the questions that have to do with surface area and volume are going to be real world. This is a very, this could be a very good question that you might see either on the SAT or on the SOL or on the district exam that you'll take next Thursday and Friday. Questions on that? We've got our 3 blanks, 16, 62.8, and 4. A cylinder has a surface area. So surface area of a cylinder is 2 pi r h. That's the lateral area, plus 2 pi r squared. That's the top and the bottom. And a radius of 9. So this equals 1890, and I know the radius equals 9, so I can rewrite that whole thing with 9s for the r. All I'm doing is substituting, and now I'm looking for the height, because the question is, what is the volume of the cylinder? So I've got to use the surface area to find the height. That's step number 1, and then use the height to find the volume. Right? So if I solve all of this, it looks a little intimidating, but I can do 2 times pi times 9. 2 times pi times 9 is going to be 56.52 h, right? I can't leave the h off. And then I can multiply all of that. 2 times 3.14 times 9 squared is 508.68 equals 1890. So it's got a lot of decimals in it, but it's not, it's just a 2-step equation. I want to subtract out my whole number. Right? So I'm getting rid of this. 1890 minus 508.68. It's going to give me 1381.32, and then bring down that 56.52h. And then divide 56.52, divide 56.52. 1381.32 divided by 56.52. I know everybody's working their thumbs and doing this in their calculator. I got 24.4. Is that what you got?
Yes.
Sweet.
Yes, it rounds to the nearest whole number, so I just put 24.
Nice. 24. Okay. Plug your values into the volume formula. So by this point, we know volume is pi r squared h. We know the radius is 9, so pi times 9 squared. And then we just found that height, which is 24. So then let your thumbs do the work. 3.14 times 81 times 24 is 6104, 6,104, or 6,104. I think the computer will take both answers. Questions on that? All right. It's going to take me a minute to close this one out and get the other one up, the spheres up. So if you could meet me on the spheres quiz, I will do any 2 problems. So it looked like a lot of people had kind of some problems with the spheres, but there was no 1 or 2 clear problems to go over. So while I open it up, you open it up and let me know which 2 problems you'd like to talk about. They were a little tougher. All right.
Miss Altree,
Yeah.
remember that ground is for the height of the cylinder? They said that 24.4 is wrong.
I will change it. It's probably because it wants 24 instead of 24.4. But I'll make a note and I'll change it before I grade them. Just like yesterday's. You said it was number 5?
That's the last one.
Okay. I don't like these fill in the blank ones. There's too many ways to make rounding errors. All right, guys, which 2 would you like to do? We've got 5 options, I think. 2 and 3 I have votes for. How do we feel about 2 and 3? Does that work?
Yeah.
Okay. The volume of the following shape, find the volume of the following shape, round to the nearest whole number. So this is a hemisphere. This is like what we did with that mock-up of the International Space Station yesterday. So we need to find the volume. Maybe if my formula sheet will open. Volume is 4/3 pi r cubed. This is a sphere. It's just cut in half. So that's why it's giving us a little stress. So V equals 4/3 pi r cubed. And then we're going to divide that by 2 because it's a hemisphere. So our r is 15. So 4/3 pi and then 15 cubed. Let's find that first. So in your calculator, do 4 divided by 3, hit enter, get 1.33, and then times pi and times 15 cubed. You should get 14,130. That would be for an entire sphere, an entire basketball. We only want half of that, so we've got to divide that by 2. So I think the answer should be 7,065, maybe with a comma, maybe not with a comma. We okay with that? Hemispheres you're going to cut in half because it's only half the shape. It's like half a grapefruit. All right. Next page, question number 3. This looks like a lot of words. The Science Museum gift shop sells lollipops that are made to look like planets. So that sounds fun. Each lollipop is shaped like a sphere and has a radius of 12 millimeters. So I can draw my sphere and I can say my radius equals 12. It's not a very pretty sphere, but hopefully we get the point. Meriwether wants to buy all 8 planet lollipops. So at some point, we're probably going to multiply by 8. What is the volume of candy that she will buy, round to the nearest whole number? So find the volume of each lollipop. So volume equals 4/3 pi and then r cubed, because volume is cubed, right? So if I go to my calculator, 4 divided by 3 times 3.14 times 12 cubed, I got 7,234.56. Did anybody get that? And that's millimeters cubed. So find out how much candy is in 8 lollipops. Wow, that's going to be a really big number. We're going to multiply that by 8. So 5, 7, 8, 7, 6. And if I rounded this to the nearest whole number, 7, 2, 3, 5, then 7, 2, 3, 5 times 8 is going to be slightly different. So 7, 2, 3, 5, and 5, 7, 8, 8, 0. Is what I get, millimeters cubed. It sounds like a lot of volume for lollipop, huh? But remember, millimeters are awfully tiny. Does that make sense? If you're looking for a whole sphere, you do the whole formula with the radius. If you're doing a hemisphere, you cut it in half. Okay. All right. How are we feeling about these, ladies and gentlemen? If you're taking the test on Friday, you feeling okay about it? Hopefully. So what I would like to do is give you some time to work on those green puzzle pieces, right? So I want to bring your attention back to here. I'm going to move all of this stuff so that we can see. You've got a bunch of stuff in the to-do list. Rectangular prisms and triangular prisms should already be done. Cylinders and spheres we looked at today. Cones and pyramids, that's what's due tonight. So you should work on cones and pyramids tonight. I'll answer questions about them tomorrow. Then we'll do some compound shapes and maybe some constructions. Remember that if you're not taking the SOL, well, really, even if you are taking the SOL, you've got this division exam down here that's due by the 29th, okay? So all of this stuff you can work on this weekend, but if you're taking the SOL on Friday, you really need to try to get the bulk of this done tomorrow so you can ask questions about it, okay? I'd like to give you time now to do that. So I'm going to stop sharing. You've got about 10 minutes to do any of those that you want, and you can private message me if you have any questions, okay?